Okay, I hope I'm audible to all my students who are attending this particular lecture for the Statistics for Business Economics Part 2 course. In this particular lecture, I'm going to start with the discussion of the 2024 question paper, which has come up at Delhi University for the Statistics for Business Economics Part 2 course. And this particular lecture is recommended for all those students who are currently pursuing BBE honors and are currently in semester 4 of your course. Okay, now all students I hope can see the question paper on your screens. This is the 2024 question paper. Okay, just to quickly discuss the instructions for all students for this question paper. Okay, apart from the basic instructions, you need to attempt all questions. However, there will be choices provided in every question. You are allowed a simple calculator in the exam, so no scientific or financial calculators, only simple calculators. You will be provided with statistical tables based on the normal distribution, t distribution, f distribution, chi-square distribution, binomial distribution. You will be provided all kind of statistical tables in the exam. Okay, so now scrolling down to the main question, we are now in this particular lecture going to start from the discussion of question number 1. So I hope all students can see question number 1 on your screens. Let's quickly start from the discussion of this particular problem in this particular lecture. So let's start with the discussion of this lecture. So within question number 1, let's look at part A. Okay, a certain brand of sugar is sold in 3 packets. Packet A costs 30 rupees, packet B costs 50 rupees, and packet C costs 80 rupees. So these are 3 packets. Okay, if 20% of all purchasers choose packet A, 30% choose pack B, and 50% choose pack C, X and Y denote the packet sizes selected by 2 independently selected purchasers. So X denotes the packet size selected by one purchaser, Y denotes the packet size selected by another purchaser. Okay, and there are 3 packets. Okay, packets A, B, and C. Determine the sampling distribution of X bar and calculate expected value of X bar. Okay, so it's a question based on the sampling distribution, which I have covered in my module in Statistics for Business Economics Part 2 course. Okay, so first of all, let me quickly come to the whiteboard and let me write this information on the whiteboard for clarity. I am just writing the main heading for completeness. This is Delhi University exam 2024. Name of the course is Statistics for Business Economics Part 2. Statistics for Business Economics Part 2. And this is recommended for students who are currently in their semester 4 of BBE honors. Okay, so we are looking at question number 1, part A. So we are given that there are 3 packs. 3 packs. Pack A costs rupees 30, and 20% of the people choose pack A. So I can say, what's the probability of choosing pack A? The probability of choosing pack is probability of choosing pack A is 20%. Probability of choosing pack A is 20%, which is 0.2. Okay, then we have pack B. We are given in the question that pack B costs rupees 50. And probability of choosing pack B, probability of choosing pack B in the question is given to us as 30%, which is 0.3. And pack C costs rupees 80. And probability I can write probability of choosing pack C. Probability of choosing pack C is given to us as 50%, which is 0.5. So I hope students have noted down the details of the question. Now, X and Y denote the package sizes selected by two randomly selected purchasers. Okay, so what are the possibilities now for two randomly selected purchasers? So either both of them can purchase pack A, or they can purchase, or one of them can purchase pack A, another one can purchase pack B, one can purchase pack A, another can purchase pack C, and so on. So that means, what are the possible combinations we can have? When two customers are purchasing packs, possible combinations for two individuals randomly selecting the packs. So both can purchase pack A. This is one possibility. One can purchase A, another can purchase B. One can purchase A, another can purchase C. One can purchase B, another can purchase A. Both can purchase B. Then one can purchase P, another can purchase pack C. Then the first one can purchase pack C, second one pack A. First one can purchase pack C, second one can purchase pack B. Both can purchase pack C. These are all possible combinations. That means, suppose I denote X1 as the pack chosen by individual one. So X1 denotes pack chosen by, it's a random variable, so let me use capital letters. Capital X1 denotes pack chosen by individual 1. And X2 denotes pack chosen by individual 2. So if I have to look at the costs now, remember pack A costs 30, pack B costs 50, pack C costs 80. Okay, so if I erase this initial portion off now, I'm erasing all this off. I hope students have noted this down in your notes. So we have the following combinations now. I can write them X1, X2. So AA means both are purchasing pack A, so 30 rupees is the cost. AB denotes that A purchase X1, the first individual purchases pack A costing 30, but second individual purchases pack B costing 50. Remember, pack B costs 50. Then AC would mean individual 1 buys pack A 30, individual 2 buys pack C 80 rupees. This combination BA means that individual 1 buys pack B. Pack B is 50, but individual 2 buys pack A, so 30. BB means both the individuals buy pack B, so 50 rupees each. This combination means the first individual buys B, so 50. Second individual buys C, so 80. This means that first individual buys C, second buys A. A costs 30 rupees. CB means first individual buys pack C, second buys pack B. Last option, both the individuals buy pack C, so 80 rupees. Okay, and we were given the probabilities, right? So probability of buying pack A, pack B, pack C. If you remember those probabilities, the probability of buying pack A was how much? 20%, which was 0.2. Probability of buying pack B was 30%, 0.3. Probability of buying pack C was 50%, which is 0.5. So here I now find the probability of x1 comma x2, the joint probability. In the first case, both the individuals are buying pack A. That means 0.2 into 0.2, which is 0.04. In the second case, individual 1 buys A, individual 2 buys B. So that means 0.2 into 0.3, which is 0.06. In the third case, individual 1 buys A, but individual 2 buys C. So 0.2 into 0.5, which gives me 1. Similarly, the next case, BA, that means 0.3 into 0.2, which is 0.06. BB means 0.3 into 0.3, which is 0.09. BC means 0.3 into 0.5, which is 0.15. Then CA means 0.5 into 0.2, which is 0.1. Okay. And 80 and 50 correspond to CB. CB means 0.5 into 0.3 again. Comes out as 0.15. And CC means 0.5 into 0.5, which is 0.25. So these are my corresponding probabilities corresponding to the values taken by x1 and x2. Okay. Now, what was the question asking us? We need to find the sampling distribution of x bar. Now, let's find x bar. Now, how do I find x bar? X bar is just x1 plus x2 over 2, right? X1 plus x2 over 2 is x bar, right? So that means 30 plus 30 by 2 comes out as 30 only. 30 plus 50 divided by 2, 40. 30 plus 80 divided by 2, 55. 50 plus 30 divided by 2, 40. Okay. 50 plus 50 divided by 2, 50 only. 50 plus 80, 130 divided by 2, 65. 80 plus 30, 110 divided by 2, 55. 80 plus 50, 130 divided by 2, 65. 80 plus 80, 160 divided by 2, 80. So these are my values of x bar. So we have found out the sampling distribution. We have found out x bar along with the corresponding probabilities. Okay. So if I now work out the sampling distribution of x bar, if I erase all this off, erasing all this off, what is the sampling distribution of x bar? I can write here sampling distribution of x bar is, what are the values taken by x bar, guys? X bar takes the value 30. It takes the value 40. It takes the value 50, 50. It takes the value 55. It takes the value 65. And it takes the value 80. And what are the corresponding probabilities of X bar? What's the probability of X taking the value 30? X takes the value 30 only once. The corresponding probability is 0.04. X takes the value 40 twice, 1 and 2. So the corresponding probabilities are 0.06 plus 0.06. So 0.06 plus 0.06 is 0.12. X taking the value 50 is 0.09. X taking the value 55. Here and here, it takes the value 55 twice. So 1 and 0.1. This is 0.1 only, guys. I made a mistake here. Let me correct the mistake. This is 0.1. 0.2 into 0.5 is 0.1. I'm correcting it. Please let me erase this off and type this properly. This is 0.1. So 55 is 0.1 here and 0.1 here. So that means 0.2. 65 is taken again twice. So 0.15 plus 0.15, making it 0.3. And 80 is taken by X bar only once with the probability 0.2. So this is my sampling distribution of X bar. This is the sampling distribution of X bar. And now the question asks us to find expected value of X bar. So expected value of X bar using the formula for expectations will be summation X bar into PX bar. So it's going to be 30 into 0.04 plus 30 into 0.04 plus 40 into 0.12 plus 50 into 0.09 plus 55 into 0.2 plus 65 into 0.3 plus 80 into 0.25. And now students can use their calculators. You are allowed simple calculators. Please verify expected value of X bar comes out as 61. It comes out as 61. So this is our answer for expected value of X bar. The question then, if I come back to the question paper, it also asks us, determine the sampling distribution of S square and expected value of S square. So we now need to find out the sample variance and then find the expected value of the sample variance. So it's a slightly lengthy job. I now need to calculate S square. So if I erase all this off now, how will I work out S square now? We found out X bar. How do I calculate the sample variance S square? The sample variance is just summation xi minus X bar square over n minus 1. That means if I apply it to x1 and x2, it's going to be 30. x1 is 30. So I can write it like this, guys. Just for more clarity, I can write it like this. x1 minus X bar square plus x2 minus X bar square, because we only have x1 and x2, over n. N is what? 2. N is 2, right? Because you only have 1 and 2. So 2 minus 1. And 2 minus 1 is just 1. So that means my S square will just be x1 minus X bar square plus x2 minus X bar square. I'm repeating it again because my denominator is just 1. Every time n is 2, right? So 2 minus 1 is 1. That means 30 minus 30 square plus this 30 minus the mean 30. So it comes out as 0. I can erase this and I can just write 0. Remember, for the first one, see, for the first combination, x1 is 30, x bar is also 30. Students can see that. X2 is 30, x bar is also 30. So s square comes out as 0. For the second case, it's going to be 30 minus 40 square. How much is 30 minus 40? 10, minus 10. Minus 10 square is 100 plus 50 minus 40 whole square. That means again 10 square 100. Every time you're dividing by 1, so I just get 200. Then it's going to be 30 minus 55, which means minus 15. Minus 15 square is 225 plus 80 minus 55 is how much? If I work it out, 80 minus 55 is 25. 25 square is 625. How much is 625 plus 225? Comes out as 850. Comes out as 850. Okay, let me verify if you're correct again. 30 minus 55 is 30 minus 55. Okay, I made a mistake here. 30 minus 55 is also 25. So it's 625 plus 625. Let me correct it, guys. 30 minus 55 is minus 25. Minus 25 square is also 625. So 625 plus 625 is 1250. Okay. Then we have in yellow color 50 minus 40 square, which is 100, plus 30 minus 40 square is again 100, which gives me again 200. Then again 50 minus 50 square is 0, plus 50 minus 50 square is again 0. 0 plus 0 is 0. Then 50 minus 65 minus 15 square up 225. Plus 80 minus 65 is again 15. 15 square is 225. 225 plus 225 is 450. Then again 80 minus 55 is how much? 80 minus 55 is 25. Square up that, 625. Plus 30 minus 55 is again minus 25. Square up, 625. 625 plus 625 is 1250. And then we have again 80 minus 65. 80 minus 65 is 15. 15 square is 225. 50 minus 65 is minus 15. Minus 15 square is again 225. 225 plus 225, 450. And the last one, 80 minus 80 is 0. So 0 square is 0. And again, 80 minus 80 is 0. So 0 square is 0. 0 plus 0 is 0. So I got the S squares now. I can now make the sampling distribution of S square. So I have S square. The values taken by S square are 0. I am writing them in ascending order. Then 200. Then 450. And then 1250. The probabilities for S square are as follows. What's the probability of S square taking the value 0? It takes the value 0 here, the probability of which is 0.04. It takes the value 0 here, probability of this occurring is 0.09, and it takes the value 0 here, so 0.25. So I can say 0.04 plus 0.09 plus 0.25. So it's going to come out as, let me write it here for you, 0.04 plus 0.09 plus 0.25 comes out as 0.38. So now I can erase this off and I can just write 0.38. What's the probability of S square taking the value 200? So 200 corresponds to the probability of 0.06. Do we have another 200? Yes. This corresponds to again 0.06. So plus 0.06. Do we have another 200? No. So 0.06 plus 0.06 gives me 0.12. So I can erase this and I can write 0.12. 450. We have a 450 here. 0.15 is the probability corresponding to it. Do we have another 450? Yes, here. Again, we have 0.15. How much is 0.15 plus 0.15? It is 0.3. So that means I can erase this off and I can just write 0.3. And then 1250. We have 1250 here. The corresponding probability is 0.1. Do we have any other 1250? Yes, here. The corresponding probability is again 0.1. So 0.1 plus 0.1 is 0.2. So I can just erase this off and just write 0.2. So this is my sampling distribution of S square. Sampling distribution of S square. And now the question was asking us to find expected value of S square. Using the formula for expectation, it's just summation S square into probability of S square. So it's going to be 0 into 0.38 plus 200 into 0.12 plus 450 into 0.3 plus 1250 into 0.2. And now students are free to use your calculators and verify expected value of S square is 409. This is my answer for expected value of S. Okay, so with this we are done with question number 1 part A. It was a long question, too much solving part required. Okay, now I stop in this particular lecture. In the next lecture I'm going to start with the discussion of question 1 part. So I hope all students have enjoyed this particular lecture. Any doubts, you can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolof economics@gmail.com. This is where I stop in this lecture.